let's do another example here. So we're just continuing from the last video, but the last video is getting a little bit long. So I wanted to start a fresh one. So we're gonna do one more example here, very similar, where we're going to solve. So notice that the question is worded differently, right? It doesn't say to find the real zeros, or to find the zeros, but it asks us to solve. But notice that you're equal 0 here. So if you're equal to 0, this is the same thing as finding the zeros. So we can start the same way by listing our possible rational zeros. So remember, I look at my factors for the constant term on top, and I look at my factors for the leading coefficient on the bottom. So my constant is 24. There's lots of options here, right? So it's plus or minus 1 and plus or minus 24, plus or minus 2 and plus or minus 12. I'm going to run out of room, plus or minus 3 and plus or minus 8, plus or minus 4, plus or minus 6. For the denominator, my leading coefficient is only 1, which is nice. So it's just plus or minus 1 here. So if you divide everything out, your possible rationals are going to be 1, 2, 3. I'm just going to go in order here. 4, 6, 8, 12, and 24. And of course, all of these are plus or minus. So I have 16 possible options for just the rational zeros, which is a lot. So the strategy I'm going to use here is I actually am going to graph this first and see if I can narrow down where my possible rational zeros are before I try to jump in and keep solving. So let's go back to Desmos. I'm going to type in this equation. So it's x to the 4th minus 6x squared minus 8x plus 24. And I can zoom out a little bit just to make sure I'm not missing anything. It doesn't look like I'm missing anything here. And I notice my highest power is 4, which is even. So it doesn't make sense that both my ending values here are going in the same direction. So it looks like I only have one real zero here, which is 2. So I'm going to use this as my jumping off point. So I know that 2 is going to work. So I'm going to start my synthetic division with 2. I noticed that 2 was one of my options as well. So it's always good to check and make sure that what you're seeing on the graph is one of the options that you have, and vice versa. So I'm going to do synthetic division with 2. Here I have a 1. Careful, there's no cube term, so I need to use a 0. -6, -8, and 24. Now I can bring down the 1 here. 2 times 1 is 2, add these together. 2 times 2 is 4, add these together. 2 times -4 is going to be, 2 times -2 is -4. I was doing the math too fast. I add these together, get -12, and 2 times -12 is -24. There's my remainder of 0, which is good. So that means that it works. So C equals 2 is going to be a factor. And remember, the setup is x minus C. So x minus 2 is going to be a factor. And this is going to be what's left over. I'm running out a little bit of room here. So let's kind of make a little area. So I have x minus 2. And then here, be careful. My highest power was 4. And this means my highest power here is going to be 3. So it's times x cubed plus 2x squared minus 2x minus 12, and then equal to 0. Okay. Now here I have my next polynomial. And again, this one is pretty difficult as well. It's not a quadratic. You could try factoring this since it's in 4 terms by grouping, but it actually doesn't work. So sometimes grouping doesn't always work. So what are you going to do here? What I would do is try synthetic division again. So you know your possible values, right? And if it helps you, if you could always regraph this and see any possible zeros there as well. But what you can do is you can try again using synthetic division, your values again, or try what you've already done. So sometimes you could even have a repeat 0 here. So let's go back to Desmos for a second. I'm going to graph that second piece. So it's f of x equals x cubed plus 2x squared minus 2x minus 12. And again, notice here, so that's the blue line, it still crosses at 2. So this is telling me like, hey, let's try 2 again. So using your graphs and kind of going back and forth is really a great tool to kind of get you started so that you're not trying every single number. So here, again, now I'm on the blue line. I see that value of 2 again. So I'm going to go try 2 with synthetic division again, just on that part. Okay, I'm going to do it over here on the right. So again, I'm going to try 2, and I have 1, 2, -2, and -12. 1 times 2 is 2, then I get 4. 2 times 4 is 8, so here I'm going to get 6, and 2 times 6 is 12, and I get 0. So again, it worked. So now I'm able to break this down a little bit more. So I have x minus 2. My c value is 2 here, so I have another factor of x minus 2. And then my remaining group is going to be x squared plus 4x plus 6 equals 0. And the reason I started with squared is because it was cubed, so I always go down one exponent to start. All right, so now again, at this point, I could look at the x squared plus 4x plus 6 graph if I wanted to. I could try factoring. Let's go back to Desmos. I'm sorry about the back and forth, but Desmos is so helpful sometimes. So let's graph that next piece. All right. So if I look here, when I graph the next piece, I don't see it crossing the x-axis, which tells me that it doesn't look like it has any real zeros at this point. So my answers are probably going to be imaginary. So I don't think I'm going to be able to factor this any further, but what I can do at this point is I could use the quadratic formula. Okay. So for this part here, again, I can't really break it down anymore. So at this point, let's go ahead and use the quadratic formula. So that's the negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, at this point, I am going to let you try this at home. So we do know the quadratic formula quite a bit now, and we've already done an example in the last video with it as well as review. So try it at home here. Your a value would be 1, your b value would be 4, and your c value would be 6. And again, we are expecting imaginary answers because we saw that there were no x-intercepts. So if there are no x-intercepts, there must not be any more real roots. So you are expecting imaginary answers here. And what you get when you're finished solving is that x is equal to -2 plus or minus I root 2. Now these over here are also still solutions, right? This is going to solve to be x equals 2, and this one is also going to solve to be x equals 2. So our roots here, or our zeros, or our answers, whatever you want to call them, are 2. 2 again, I don't have to write it twice. And then -2 plus I root 2 and -2 minus I root 2. Now remember, because we have a 4 here, you can't have up to 4 solutions. So I actually do have 4. I have 1, 2, 3, 4. Now I do have a repeat here, but you can still see where those 4 solutions come from. So these are the zeros in this case. And again, this is definitely a more challenging one. So what I was doing here is I'm using multiple strategies in one. So I first found my possible rational zeros, and I kind of had a heart attack because I saw how many there were and how I didn't want to do this much work. So I went to the graph, and that graph showed me that the x-intercept was 2. That x-intercept is a 0. So I was able to use 2 first to start with to help me with my synthetic division. So I wasn't wasting time trying everything else. Then I did the same thing here. I graphed this one, and again, I saw the x-intercept of 2. So I used synthetic division again with that 2. Then when I graphed this one, I saw no x-intercepts. So if there are no x-intercepts, the solutions are going to be imaginary. So I knew I couldn't factor that. I knew I had, or use synthetic division. I knew I had to use the quadratic formula and a different strategy there. So we're applying a lot of different strategies in these more complicated problems.